We're going to wrap up scatter plots today by looking at line of best fit. So your line of best fit follows the trend in the data and helps us make predictions. Our line of best fit is a straight line that's going to go through the maximum number of points on our scatter plot and also balancing an equal number of points above and below the line. Got an example for us below about Chloe has a part-time job at an ice skating rink selling hot cocoa. She decides to plot the number of hot cocos she sold relative to the day's high temperature and then draw a line of best fit. So you can visually see right there, they've already created that scatter plot. And here is a line of best fit going right through the center of our data. We've got the same number of points above and below, and it's going right through the middle following that trend in that data. That's a line of best fit. So let's answer some questions below. Number one, what does the line's y-intercept represent? So we're looking at the line, our line of best fit, and that is going to represent predictions that we could make about additional values on our scatter plot. And so let's look at our y-intercept. So our y-intercept would be up here going through our y-axis. Would it represent A, a prediction of the temperature when 0 hot cocos are sold? Our y-intercept looks like it is 0, something like 120. Our x value here is about our temperature, and y is our hot cocoa. So a prediction of the temperature when 0 hot cocos are sold, that's not correct at all. Our y value is 120, and that's for 120 hot cocos. B, the prediction of the number of hot cocos sold when the temperature is 0 degrees Fahrenheit. That's a possible answer. Let's keep checking. C, the actual temperature when 0 hot cocos are sold, and D, the actual number of hot cocos sold when the temperature is 0. Not actual. We'll see through our examples here when we are looking at our line of best fit, we're considering values along our line. We're considering what might be expected or predicted. When we're talking about actual points on our scatter plot, those are actual values that have occurred. So it's not C or D. And as I said, B was our best answer. It is a prediction because it's the y-intercept of our line of best fit of the number of hot cocos sold when the temperature is 0 degrees Fahrenheit. Number two, what does the point 3583 represent? So this is an actual point, actual data that had occurred. So let's go to our graph, and I see right here is that point 3583. And I'm just going to label here XY. Our X is our temperature. 83 would be the hot chocolate, hot cocos. So what does that represent? A, when the day's high temperature is 35 degrees, Chloe should expect to sell 83 hot cocos. Okay, that is a possible answer. We do have 35 is our temperature. What about B? When the day's high temperature is 35 degrees, Chloe sold 83 hot cocos. This actually occurred. I think that's a better answer. I'm going to keep B in mind. Let's look at C. When the day's high temperature was 83 degrees, that's not correct. 83, that's represents our Y value or the hot cocos. And D, when the day's high temperature, again, 83, not correct. So A and B have the variables correct for X and Y. A said what she should expect. That's like a prediction. That's if we were looking at our line, but we are considering an actual point on our scatter plot. So it's how many she actually sold, B. Continuing on with number 3, what does the slope of the line represent? Again, if we're looking at any kind of question regarding our line, it's when we're thinking about predictions of what might happen or what we might expect to happen based on our data. Our slope, of course, is change in Y over change in X. Our Y value is that hot cocoa, and our change in X is our temperature. So we want the rate of hot cocoa over temperature would be our slope or our rate of change. Let's look at our answer choices. A prediction of the temperature when 1 hot cocoa is sold. Maybe. We are considering a prediction because we want the slope of our line. But look at B, we have that term rate of change. I know that represents slope. B, the rate of change in the day's high temperature for every additional hot cocoa sold. That's a rate of the high temperature over hot cocoa. That's backwards from what it should be. We need to have that flipped. That's wrong. C, a prediction of the number of hot cocoa sold when temperature is 1 degree Fahrenheit. D, we have the rate of change in the expected, another term for prediction, rate of change in the expected number of hot cocoa over the day's high temperature. That's correct. Hot cocoa over temperature. That's our y value over our x value. D is our best answer. We have rate of change, relates back to the term slope. We have the term expected because we're using the line to make predictions. It's what we should expect to see, the number of hot cocos compared to the high temperature. Number 4, what does the point 2100 on the line of best fit represent? So we're still talking about a prediction, what we might expect to happen, and we're thinking about the point 2100. Let's just imagine where that might be. 2100 would actually fall on that line right there. 2100. That would be 20 is our x value. That would be our temperature. Y would be the number of hot cocos that Chloe sold. A, when the day's high temperature was 20 degrees. That does fit. Chloe sold 100 hot cocos. That might fit. Let's keep checking. B, when the day's high temperature was 100. Nope. C, when the day's high temperature was 100. Nope. D, the day's high temperature was 20 degrees. Chloe should expect to sell 100 hot cocos. I'm going to go with answer choice D because we are talking about a point that does not already exist on our scatter plot. It's a point along our line where we're making a prediction about things we might expect to happen. So Chloe might expect, when the temperature is 20 degrees, to sell about 100 hot cocos. On our second page, we have a new situation. We've got a researcher studied the relationship between the number of times a certain species of cricket will chirp in 1 minute and the temperature outside. Her data is expressed in the scatter plot and line of best fit below. Our x coordinate is the chirps. Y is the temperature. Let's look at question number 5. What's the meaning of the y value? Let's go ahead and label that. That's our temperature. So what is the temperature on the line when x equals 90? And remember, x is the number of chirps. I'll label that for me. X is 90. We might have a point here. And we'll find our y value, right? It might be 63. That's a guess. X is our chirps. Y is the temperature. So let's see. A, the predicted temperature, maybe in degrees Fahrenheit if the cricket chirped 63.4 times. No, I know that the cricket chirped 90 times, right? There were 90 chirps. That's what I know. B, the actual temperature in degrees Fahrenheit when the cricket chirped 90 times. Yes, but not actual. We're talking about the line of best fit. So these are predictions still, what we might expect to happen. Prediction. C, the actual temperature. Nope, not actual. We're talking about the line of best fit, picking a point along that. D, the predicted temperature, maybe, in degrees Fahrenheit if the cricket chirped 90 times. Yes, yes, yes. Answer choice D. C, what's the meaning of the x value on the line when y is 75? X is chirps. Y is the temperature. So what is the meaning of the x value when y is 75? Let's see where 75 is. And we are on the line again. So we're looking at predictions, what we might expect to happen. A, the number of times the cricket could be expected. That's okay, prediction, expected, if it's 120 degrees. No, we said 75 was the temperature. B, the actual. Nope, we're looking at a prediction on our line of best fit. C, the number of times the cricket could be expected to chirp if it's 75 degrees. I'm really liking that answer choice. Let's double check. Answer choice D, the actual. Nope, it's got to be C. We're using our line of best fit. We're anticipating a point along that line at when y is 75. That would be the expected or predicted amount of chirps when it's 75 degrees outside. So there's wrapping up our scatter plots with lines of best fit. A line of best fit is a line going through our data, trying to balance the same amount of points above and below, and they can help us make predictions about what might happen if there were additional values on our scatter plot. They are predictions, what we might expect to happen. So read those questions carefully. You can see we've got lots of examples here to practice, and I'll see you in class. Bye.